All right, so let's use these two technologies that we have been talking about in object relational mapping and web services. Within the as they are implemented by the by JPA and the JAX-RS interfaces. Right? JPA being Java's implementation of the concept of object relational mapping, right? And JAX-RS as being Java's implementation of web services, right? Way back when, again at the turn of the century, there was a huge competition amongst the biggest players, IBM, Sun Microsystems, and Oracle and whatnot. And again, web services was being pushed as the solution to everything. And says everybody had a solution where push this button and you have a web service running and it's done, and finally we have that. It's trivial now to create a web service, and it's really cool. Not that it solves everything, but it's a really really powerful technology. All right, so let's use JPA and web services. So we'll create a new environment where we can play with this. Let's see. Let's open up STS. Taking a while. And we're going to create a new Spring project, and we're going to add a couple of dependencies. One of the dependencies we're going to add is JPA. Right? It says I want you to use, install the JPA libraries. Also, I want to add a web project as a dependency so that we can use some host a couple of web technologies and test it out. Okay, it's ready. Let me just close some of this stuff. Let's see. Let's a new Spring started project, and we'll 2019 already. Wow. Okay. Okay, so let's add JPA, web, and an embedded database. We'll say finish. All right, so we have that. One of the where to go? Where did it create it? Oh, there it is. One of the things that it's configuring here is in the resources we have a new file called application.properties. Right? If we go back to the when we were talking about JDBC, one of the criticisms or one of the misgivings of using JDBC was that when we were writing our DAOs, our data access objects, was that internally we were loading the driver, right? We were doing class.forename, remember that? And we were providing the name of the driver, which in this case was the MySQL driver, right? And the other aspect was that we were configuring internally when we were going to fetch a connection to a database. We were using the URL right there. We're saying JDBC : MySQL : / and then the port name and whatnot, and the server was running. Okay, so those two facts kind of went counter with the idea that Java wanted to be able to be vendor specific, right? That you wanted to write code that was agnostic to the vendor. But right there in the source code, we had the actual driver that we were loading, and also a URL that was dependent on the particular driver that we were using. Okay, we were loading the class dynamically, and we knew exactly where we were connecting. So that if tomorrow we wanted to change to some other database, we actually had to go in the source code and modify the driver, modify the URL, and now our code was no longer agnostic to the vendor. All right. To get around that idea, JPA allows us to instead configure that outside of the source code, right? In either XML configuration files or properties files like this, right? Where we can configure the URL, we can configure any username and passwords, any other configuration that would not impact the source code. Now, truly, our source code will be agnostic to the vendor. We would only have to update a couple of configuration files, and our source code would run just as well. Okay, so again, delivering on the promise of being vendor agnostic. The other thing shortcomings of using JDBC was that we were creating a connection, right, a database connection, using that database connection, and when we were done, we were throwing away that database connection, right? And that typically is a very expensive way to go, right? It's typically a database connection is a fairly expensive object to get a hold of, right? And to initialize and to get it going. And once you have it, you'd like to be able to hold on to it as much as you can before releasing it, right? And we had no mechanism to speak of to keep track of this connection and reuse it later on. Okay, whereas to get around that issue, JDBC created a JavaX.JDBC version, okay, or JavaX.SQL version, right? That is it's much more advanced than the out-of-the-box JDBC version, right? In this other version, what JDBC does is that allows it to keep track or cache connections as they become available, right? It allows servers, such as the one we're going to build right now. It allows these servers to once they boot up, once the server boots up, to instantiate any number of connections, right? Keep them around, and then share those connections amongst multiple threads, right? And what this allows you to do is have a much better performance than creating and throwing away, and then creating another one and then throwing it away. Instead, you have a pool of connections, right, that are instantiated once. So you incur in that cost of creating these connections only once, right? When the server boots up, right, it creates, say, 10, 20 connections, keeps them around in what is called a connection pool, right? And then as threads need connections, they ask for a connection from this pool, right? And the server gives them this connection. Once the thread is done with the connection is not destroyed, is put back into the pool so that other threads can use that connection later on. Okay, so this improves performance quite a bit. You can also configure the server to throttle throughout the day as the load on the server changes over the day, and in the morning, maybe the load is fairly low, and over the day it goes up, and perhaps 10 connections is not enough, right? And so it can be configured to throttle and instantiate 5 more connections, yes, and perhaps go up to maybe another 10, and then another 20, up until it hits perhaps a limit, right? And then when it reaches this peak of the day, as folks go back to work, the load might go down again, and it can release these connections as it goes and decrease its footprint as it adapts over the load over an entire day, right? So yeah, so the newer versions of JDBC that allow you to configure these things outside, it's much more powerful, it's adaptive, and certainly much better performance. Okay, all right. So how do you configure these things? So here we have one of the simpler configurations, which I'm going to copy here. Ooh, this is too big. What the? Okay. Yeah. So here's a configuration So instead of, for instance, configuring in a DAO the URL that we're going to be using, instead we configure it outside. Right? We say that this is the URL that you're going to be using. It's MySQL, right? But now no longer does it live in the source code. Right? Now we can truly leave the source code independent of the vendor. And this points to some URL wherever your database is running. If it's running local, then this will be localhost. And then the database that we might want to use. So let's create a database to play around with. Let's call it create schema, and this will be CS5200, summer 2018, and this will be to play around with JPA. So we'll say apply, and we create that schema. Okay, excellent. So we'll use that same schema right here. And let's create maybe a couple of users. I'm going to make sure not to use my password like I did the other day. And I put it on YouTube. I don't remember what the password for this was, but I'll just do 5200 and 5200. And this is a DBA, has God powers. We'll say apply. Okay, so now I know the password. So this is CS5200 and CS5200. So again, we're no longer configuring this inside our source code. We're configuring outside. A couple other things. As the ORM interacts with the database, one of the more interesting things to do is to look at exactly what SQL it's using to talk to the database. Right? So we're no longer going to write SQL. Instead, we're going to be using these ORMs to write the SQL for us. Right? So for instance, in development, it's very interesting to turn on show SQL. Right? So you can debug if you look at the SQL, it says, no, that SQL is not right. Okay? You might not agree with the ORM over the SQL that is being used. In production, certainly you would turn this off. Right? In production, you don't need to look at this SQL. You would turn it off and say false. The other thing that you might want to turn on is that since the mapping is going to happen, right, we're going to give it a data model, a Java data model in this case, we wanted to generate for us the equivalent relational schema for us. Okay? And so this DDL, this is the data definition language. We're going to do all the create operations. It can be configured to either create, right, or update, and there's another one, I forget which one. So create, as the name suggests, what it's going to do is that every time the server boots up, it's going to blow away your database and it's going to recreate it from scratch. All right. So if you have data stored in there, you have records and whatnot. Careful. If you say create, right, it will dump all you will drop all your tables. You'll lose all your data, right, and it will recreate the schema from scratch. If you've already have a schema already running, if you already have a legacy schema that is there, you want to map it to a data model. Typically, you want to maybe just do an update, right? Where if you make any changes in Java in your data model, then those changes are made gradually onto the relational database, right? Other things here is that what naming do you want? What strategy do you want? Because in Java, typically your naming convention is that you use camel casing, right? Everything's lowercase except the beginning of every word, right? Except for the first word. Yes, as opposed to in SQL, typically you instead you use underscores, right? Because in SQL, typically it's case insensitive, right? It doesn't really matter what case you use. So if you have long phrase or sentence or something that is a compound word, typically you would use underscores instead. So this is you can use several naming schemas, right? The default is to just make everything lowercase, right? It just grabs your nice naming convention that you have in Java and it just makes everything lowercase. This improved naming strategy, at least it finds the uppercases and it transforms to underscore and then the letter. Right, so it makes it easier to read. Also, depending on the vendor, right, what database you have, you can tell, well, depending on the version of the database, it will have a different dialect, right? And depending on that specific vendor, there might be some optimizations that are specific to that particular vendor, right? So you can turn on and say, hey, I'm using SQL 5, MySQL 5 dialect. Use whatever features that are specific to that particular vendor. And there's a whole bunch of other configurations we're not going to get into that you can optimize here and there. All right, so we have that. Let's keep going. Well, another thing that you might want to consider is to look at the POM file that was generated when the project was created. In particular, we want to take a look and make sure that the JPA JPA was added, and it wasn't. Was it? I don't see it. Oh, okay. So there's JPA, okay. Here's web. The other thing that might be missing from here is depending on your vendor, right? And depending on what database you're using, you will need a driver, right? Implemented typically as a jar file. To actually delegate, do all the JDBC low-level communication to the database. In this particular case, we are using this MySQL version 5145. I'm going to copy that, and I'm going to add that as a dependency at the bottom down here. Okay, so what that's going to do is that it's going to download the driver and copy it into the Maven repository so that it can be used and linked to this project. Okay? All right. Let's see. All right, so the data model. So let's look at this data model. Some of you might recognize this. Here we have a couple of interesting relationships. Here we have a top-level base class user. And then we have a couple of derived classes, faculty, student. We have a couple of one-to-many relationships between the faculty, courses, and sections. We have an association there, an enrollment that associates like a many-to-many between these two, and the enrollment captures some information about that particular enrollment. Okay, and so let's implement this next. All right, let's see how we can use JPA to implement this data model, and we'll do that next.